Bismillahirrahmanirrahim. Okay, in the previous video, I talked about the database and what is the database, why do we need database. I said that the first step in designing a database is designing the data semantic model. Um, I said that ER is a method for semantic modeling, and in the ER in the ER diagram we have three different elements: entity, relationship, and attribute. We talked about what is an entity, what is the relation, and what are attributes. Okay, we talked about this in the previous video. And then I said that the next step we have after semantic modeling is the logical model. Uh, the logical data model is the next step we have in modeling and designing a database. Okay, we have to convert the semantic model to a logical model. In a logical model, there are several parts: the structure, the integrity, and the operations. Okay, one of the logical models that we have is the relational data model. Okay, relational data model is a very good model that we can use, and we could convert the semantic model that we have designed in the ER diagram. We could convert it to a logical model, which is here we are talking about the relational data model, which is a logical data model. Okay, in the relational data model, the data structure is a relation. What is a relation? Okay, so before I continue, I should focus that uh, first, for designing a database, we have to do the semantic data modeling, and after that we have to convert this semantic model to another model, and the next step, and this conversion is done to um, a model which is used in the database. Here I want to talk about the relational data model. Why do we want to talk about this? Because the NoSQL database, which is the main concept of our course, it was proposed because of the limitations of this model, of this relational model. The relational databases are databases that are being used in many software, but they have some limitations. So we want to talk about them. Okay, first of all, in the relational data model, which are the basis of the relational database, we have an important concept, which is the relation. Okay, relation is the structure of the data in this model. And what is the relation? The definition of the relation is a subset of Cartesian product of several sets. Okay, that's the definitions that we have in mathematics. Okay, but if we want to say it a bit easier, a relation is like a table. Okay, a relation is like a table. For example, if I have a customer and I have some data about the customer, okay, this customer, it has some attributes. For example, the customer ID, the customer name, the status of the customer. Okay, then each of my customers are here: Google, Amazon, and Apple. These are my customers. Okay, this table is the relation, is a is a relation. Okay, so in the relational database, the structure of the data is tables. In our database, we have some tables. Okay, our database is composed of some tables that we have here, and each table has some attribute. And now you may ask that what how do we design these tables? Okay, the answer is we design them based on the semantic model. The semantic model that I talked about, which was the ER diagram, that is a main step in designing the database. These tables are designed based on our semantic model. Each of the entities that we have in the ER diagram, they are converted to a table. Okay, and some of the relations that they have multiple attributes, they are converted to tables too. So the tables are the entities and the relations and the relationships in the ER diagram. Okay, so the relational database, it is designed based on the ER model, and the ER model says that we have some entities and some relationships. All of the entities are tables in the relational database, and the relationships in the ER model, most of them, they are tables too in the relational database. So as I said, the main data structure we have in the relational database is the table. Okay, you see this table here. This table, the attributes. Okay, I talked about attribute. Each of the tables, they have some attributes. They are the columns of the table. Okay, for example, the customer, it has three attributes: customer ID, customer name, and status. This table, it has some columns. The columns are the attributes, and it has some rows. The rows are the instances of the data. Okay, so the structure of the data in the relational database, it is a table. That's very important. Okay, the second subject that we have here, it is the integrity. What is integrity? Okay, integrity is a very important subject in the database. Integrity means that the data that is being stored in the table, in the database, they should be always correct, consistent, and accurate. Okay, so they should be correct, as I said here. The accuracy, precision, and consistency of data throughout its life cycle, that's called integrity. Okay, so integrity means the data should be accurate, precise, and consistent. Now, what does this mean? What does accurate, precise, and consistency mean? Okay, for example, if we have a database for the university, and in the university we have some students. Okay, each student, each student has a average. Okay, the average, or in Farsi, muadil, average. Okay, now, for example, uh, one of the student, it the average of one of the student is 18.25. Okay, 18.25. And then in the database I store 18, not 18.25. Okay, if this happens, we say that the data is not accurate, so we don't have integrity. So accuracy, it is most of the times, is about data which is a number. It is about numbers. Okay. Precision. What does precision mean? Precision means that the data should have a correct value. Okay. For example, uh, one of the attributes of the uh, student is, again, is the average. Okay. Average should have a value between 0 and 20. Okay. 0 and 20. That's the average. Now, if the average gets a value, for example, 25, that's the incorrect value. That's an incorrect value. Okay. So we say that we don't have integrity. We don't have integrity, and that's a problem we have here. The third issue is consistency. Consistency, what does it mean? Consistency means that if we have some data that they have been repeated in the database, okay? For example, the name of the student, it is being repeated. Okay. And these data that are being repeated, if we change one of them, if we change one of the copies of the data and don't change the others, okay? Don't so we have some data that are copies of each other. We change one of them and we don't change the others. If we do this, the data is not consistent, so that we don't have integrity. Okay, so consistency is a, a part of integrity. If we don't have consistency, then we don't have integrity. Okay, now this is the definition of integrity. Okay, so we need to have these features in the data in throughout the life cycle of the data. Okay, now for controlling and guaranteeing the integrity in the database, what do? We define some rules. Okay, we guarantee integrity by defining some rules. We have two types of rules. One of them is user defined rules, and the second one is general rules. Okay, user defined rules and general rules. Okay, what are user defined rules? These rules are defined by an authenticated user. Okay, it means a user that has the access to define these rules. These rules depend on the operational environment. What does operational environment mean? It means that the environment that we are designing a database for it. For example, we are designing a database for the university, so the operational environment is the university. Okay, so uh, uh, a user defined rules are rules that are depends on the database. It's different in every database. For example, in a university, we say that theoretical courses in a group number D111, they have unit 3. Okay, this is a specific rule only for a specific university. Okay, so we define these rules and we say that if we have a theoretic course in a group means, for example, computer group, electric group, okay, the groups that we have in the university. If we have a theoretical course in group number D111, the unit of the course should be 3. It can't be 2, it can't be 1, okay? That's a rule that we have defined, for example, in a university. Now, the second type of rules is general rules. General rules mean that the rules that are independent of the environment. Okay, it means that these rules exist in all of the databases. Okay, we don't care that what is the database. In all of the database, we have these rules, general rules. There are two rules here: entity integrity and referential integrity. These are the two rules that we have here. Okay, now, well, what is entity integrity and referential integrity? Before I talk about this, first I have to talk about another concept that we have in the relational database, and that is keys. What is keys? Keys is a very important subject in the relational database. Keys are a facility for accessing data quickly. That's the main aim, the main thing that we need keys. We need keys for accessing data quickly. That's a very important thing. Okay. For example, in a table, we may have millions of data, and we want to access them. So we have to have a key to access each of the data that we have in the table. Okay. Some keys are for establishing relations between tables. Okay. Okay, so keys may have two different features. The first one is for accessing data quickly, and the second one is for establishing relations between tables. Okay, so keys may have two different roles: for accessing quickly to data and for establishing relation between tables. Okay, we have two important keys: primary key, foreign key. Okay, what is the primary key? Primary key is a unique attribute or group of attributes in the data. Okay, so primary key is a key that the main feature is that it should be unique. It should be unique. For example, you see in this table that STUD ID, the ID of the student, it is a unique attribute. Each of the rows has a different student ID, so it's unique. So it could be a primary key. Okay, uh, that's very important here. Okay, uh, so the if an attribute it has unique values for every row of the table, we say that that attribute is a primary key. Okay, so that's the definition of primary key. Primary key is a facility for accessing data quickly. Okay, is a facility for accessing data quickly. And the second type of key is foreign key. Foreign key is a different type of key. Foreign key is a field is for establishing relationships between tables. Okay, so we define the foreign key when we want to have a relationship between the tables in the database. Okay, a foreign key is a field in one table that must match a primary key value in another table in order to establish the relationship between the two tables. Unlike a primary key, a foreign key needs not to be unique. So, foreign key is a type of key that is for establishing relations between tables. Okay, for example, look at this example. Okay, here we have two tables. The first table here, it is the departments table. Okay, each row of this table is a department in the uh, in a place, and the next table is the teachers that are teaching in different departments. Okay, so here we have two tables, departments and teachers that are teaching. Okay, in the first table I have two attributes, depth code and depth name. The code of the department and the name. In the second table I have four attributes, teacher ID, depth code, F name, L name. Okay, now you see here that in the first table here in the departments table, what is the primary key? Okay, when we look at this table we see that the depth code is the primary key. Okay, usually the primary key is a number, so here we have a number here. Okay, and you see in the second table that again we have the depth code here. But here, the depth code is not a primary key. Okay, but the depth code in the second table, the values of this attribute, all of them are in the values of the depth code in the first table. Okay, so this depth code attribute, it is a foreign key because it is establishing a relationship between these two tables. If I didn't have depth code in the second table, then the two tables couldn't be related to each other. When we add this depth code to the second table, then we could define a relation between these two tables. Okay, so this is the foreign key. So in the second table, this depth code, it is a foreign key. The foreign key gets its value from a primary key in another table. Okay, so the values of this depth code, which is a foreign key, it is from this depth code here, which is the primary key. So we had two different keys, primary key and foreign key. Primary key is for accessing data quickly, and the foreign key is a key that we use for establishing relationships between the tables. Okay? Now, let's go back to our discussion about the integrity. Okay, we said that we the second type of rules that we have in integrity are the general rules. The general rules are the rules that are correct for all the databases and they are not dependent on the environment. The first one is entity integrity. Entity integrity is a rule that is being executed by the database management system. Okay. Entity integrity means that the primary key of a table shouldn't be null. That's the integrity rule. Okay. The primary key of a table should not be null. Okay. That's the entity integrity rule. The second rule in the general rules is the referential integrity. Okay, as you see, the entity integrity is a rule about the primary key, and the referential integrity it is a rule about the foreign key. Referential integrity is specified between two tables. In the referential integrity constraints, if a foreign key in table 1 refers to the primary key of table 2, then every value of the foreign key in table 1 must be null or be available in table okay. So referential integrity says that if we have a foreign key in a table, the values that the foreign key could have are the values that we have in the primary key, that the foreign key is referring to the primary key. For example, here this depth code, it was a foreign key. The values of this depth code are the values that we have here in this table. This foreign key is referring to this primary key here. Okay, each of the foreign keys that we have, they are referring to a primary key, and the values of this foreign key should be in the values of this uh, the values of this foreign key, they should be in the values of this primary key. Okay, that's the referential integrity rule. Okay, so these are the two rules that we have in the for integrity in the relational database. And here you see that these rules are very important for having integrity in the database. Okay, so we talked about the structure of the relational database, which was the table. The table was the data structure that we have, and we talked about integrity, and we said that integrity, what does integrity mean, and how could we guarantee integrity using the rules, the user defined rules and the general rules, which were two rules: entity integrity and referential integrity. Okay, the third and the last part of the data model of the relational data model is the operations. Okay, in the relational database we have a language for doing operations in the database. The language is called SQL, Structured Query Language. This is a language that is used for doing operations in the relational database. There are many commands in this SQL language. I'm just talking about some of them here. For example, create, drop, alter table. This is a group of commands for creating a table, for deleting a table, and for alter. Alter means changing the structure of a table. It means adding attribute, removing attribute, changing attributes. Okay, the second group of commands: insert, update, delete. Insert is for adding rows to the table. Update is for updating the rows of the table, and delete is for deleting the rows of the table. These three commands, they make changes to the data. We call them the write operation. Write operations mean the operations that are changing the data. On the other hand, we have the select command. The select command is for reading data. Okay, it is for reading data, and we use this command for reading data. For example, here I am creating a table, create table, persons, and these are the attribute, person ID, last name, first name, address, city, and these are the types of each of the attribute. Okay, these two are strings, and this one is an integer. The person ID is an integer. These are some examples of insert, update, delete. Insert into customers. Okay, we want to add a customer. We do it like this. This is the command we should execute for adding a customer to the customer table. Okay, here the name of the table is customers, and the update command here, we do it for updating data in the customers table, and the delete command is for deleting the rows of the customers table. And the select, as I said, select is for reading data. Select customer name and city from customers. Okay, we have stored some data in the database and in the tables, and then we want to read them. It's very important. All of the reports that you see in every application, these are read operations. The read operations are very more than the write operations. Okay, and okay, these were some operations that I talked about. I will talk about the rest of this subject in the next videos. Thanks.